Okay, so we're going to talk about negative exponents. And then we're going to mix in all that stuff we did last week as well. So it's just going to, it's an additional thing to what we've already done with exponents. So all of those rules still apply. If we're multiplying things and the bases are the same, what do we do with the exponents? Add them, right? If there are parentheses and an exponent on the outside, we do what with the exponents? Multiplication, okay? If we're dividing and the bases are the same, what can we do? Subtract. All of those things are still in play. We haven't taken those and said, oh, we're done with that. It's still part of the game. So all that's still happening. We're just going to have negative numbers mixed into it with what we're doing today. There's still going to be some positive numbers. In fact, at the end of every problem, we want to change them back to positive numbers, and I'm going to show you how to do that. So, the other rule that we talked about last week, anything to the zero power is one, always. Okay, so that's the other thing that we need to keep in mind. So all of those rules we talked about last week, still part of the game as we deal with negative exponents. Okay, negative exponents. The negative exponent property. When you're doing the negative exponent property, it's not a everybody does it this way kind of rule, but I think it makes things easier for you if you'll do this first. If you'll do all other properties of exponents first. So do all of the other properties before you start fixing negative exponents. The reason that I try to do it that way is because when I start a problem, if it's got negative exponents in it, and I start applying the negative exponent property before I do the other ones, I may have to go back and do the negative exponent property again. So it'd be like doing, be like putting your socks on, or putting your shoes on before you put your socks on, kind of thing. You're going to end up having to redo that, right? So that's the idea. If you'll do all of the other properties first, then you'll only have to apply the negative exponent property at the end. Okay. And what the negative exponent property is if you have some base, we're going to use an A, and it has a negative exponent. Doesn't matter what number that is, just a negative exponent. What it can do is right now, that is A to the negative n. If I write that as 1 over A to the positive n, that's saying the same thing. Right now, this is technically in the numerator. It's in the top. If we move it to the bottom, it changes signs to a positive exponent. That's what happens with negative exponents. To make them positive, you move them from where they are to the other spot. So if they're in the numerator and they're negative, we move them to the denominator and make them positive. Okay? If it's 1 over A to the negative n, right now it's a negative in the denominator. To make it positive, we move it up to the top, and it becomes A to the positive n. Okay? Makes more sense when you see an example of it. So let's look at an example. X to the negative 2. Okay? We want to change that to a positive exponent, and that's the rule. When you get done with a problem, it should only have positive exponents in it, unless we're doing scientific notation, and we won't do that till about Wednesday. Okay? So negative exponent on a variable, we want to move that to make it a positive exponent. So what you do is you just move it to the bottom and make it a positive 2. Seems like magic. It's not. It's the property, the negative exponent property, that allows that to happen. Okay. I think it makes even better sense when there's something else in the problem. 3y to the negative 4. So what part of that has a negative exponent? 4. The y does. The 3 has what as an exponent? Positive 1, right? So which one needs to move to make it positive? The y is the only one that needs to move. So that means the 3 to the first power is going to stay up top. You're going to have 3, and then we're going to move the y to the 4th. We're going to move it to the bottom to change it to a positive exponent. The 3 stayed up top because it already had a positive exponent. It had that 1 that was there. The y moves down to change to a positive. Okay. Same thing can happen if you've got 1 over x to the negative 3. So the negative exponent is in the bottom already. Okay. But we don't want negative exponents in our answers. That's what we only want, positive exponents in our answers. So it's negative in the bottom. To make it positive, we move it where? Up to the top with the 1 that's already there. So that's going to give us x to the positive 3. Technically, that 1 is in front of it. So this is what we're finding for answers. We're changing negative exponents to positive exponents to find our answers. Let's say we had x squared over y to the negative 5. Which one needs to move? Why the y? It's got a negative exponent. Why not the x?
Because it has a positive exponent.
It already has a positive exponent. So if it's positive already, don't move it. Just move the one that needs to be moved. So this guy needs to be moved. So that's going to leave us x squared and then y to the positive 5 up top. Technically, this is over 1, but we don't have to write that. Okay. When we move it from the denominator to the numerator, the negative exponent property says that changes the sign. So we move from the bottom to the top, it changes signs, or move from the top to the bottom, it'll change signs. That's what that property does for us. X to the negative 3, y to the 6th. So there's no fraction bar in this one. There's not. It doesn't look like it's written as a fraction. So that means both of these right now are where?
Well, one of them's negative.
One of them's got a negative exponent, but are they in the top or are they in the bottom? If there's no fraction written in there, they're in the top automatically.
We need 3 more.
Get them. Go get them. I'm not going to hand them to you. All right, so if there's no fraction bar already written there, then they're already in the top. So to fix that, you need to fix the one that's the negative exponent. So the x needs to move to the bottom. So what it does is it leaves the y to the 6th on top. Now we put a fraction bar in there. X cubed moves to the bottom. Okay. X to the negative 2 over y to the negative 4. So these are both negative. So that means both of them need to do what? Move. Where does the x go? To the bottom, and it changes it to be positive x squared. And what goes to the top? The y becomes y to the positive 4. Okay. So both of them were negative. It basically flipped the fraction and changed the signs. But this is a negative, so it moves to the bottom and changes to a positive exponent. This was negative. It needs to move to the top and change to a positive exponent. Okay, so anytime it's a negative exponent, at the end of the problem, we're going to fix the negative exponents. Don't fix them until the end of the problem, though. Do every other property first. Because if you do the negative exponent property at the beginning, you may have to go back and do it again at the end. Okay, just trying to save you a little bit of work. It doesn't necessarily make it wrong to do it at the beginning, but why would you do something twice when you could just wait and do it once at the end? Okay. Like making your bed right before bedtime. What's the point? Okay. All right. So, unless you were my mom, and there is a point. You had to make your bed today, and you didn't. So you got to make it now. And then that's all right. So let's start mixing in those other properties that we talked about last week with some negative exponents as well. So let's start with x to the third power times x to the negative 6. What's the rule or the property that we're going to do? What are we going to do with the exponents here? Add them all together because they're doing what? They're multiplying those things that have the same base together. So what exponents are we adding together? Hope it didn't break. 3 and negative 6, and there's a positive 1 there as well. So we got 3 plus 1 plus negative 6. Negative 2. So positive 4 plus negative 6 be negative 2 out of that. Now, that has a negative exponent, so that means we need to fix it. How do we fix that? Put the x squared on the bottom. What's on top now? 1. If there's nothing else there, it's a 1. It's just like if you've got a x squared and they say write it as a fraction, you just put it over 1. Same thing happens up top. If nothing else is up there, it's a 1 understood to be there. Let's say we had x to the third times y to the negative 7 times x squared y to the 4th. So again, it's taking the properties that we did last week and mixing in a negative exponent with those, okay? So this one's got 2 different variables in it. So that means we got 2 different bases, right? Which ones go together? X's go with X's, Y's goes with Y's, right? So what do we do with the exponent on the X's? Add them up. So that's going to be x to the 5th. What do we do with the Y's? Add them up. Negative 7 plus 4. Negative 3. Good, Aubrey. Negative 3. And then remember, last week I kept saying always put your answer in the top to start off with. This is why. Because when we start putting our answer in the top, now we got to fix it. Okay? So what moves? The y moves. Good job. So x to the 5th stays up top. What's on the bottom? Y to the positive 3 power. And then that is done, simplified for that problem. Okay. See about this one. X to the 2nd power, y to the negative 2 power, all raised to the negative 4 power. Multiply those exponents by negative 4 is what Tyler says. Is that right? Yeah, he's smart. He's got it right. So that'd be x to the what? Negative 8. Y to the negative 4 times negative 2 is, it'd be negative times negative is a positive. So that's positive 8 on the y. Okay? The x needs to move. Good, Robert. So what's on top? Final answer. Y to the 8 over x to the positive 8. Okay. If we had moved the negative exponents at the beginning, we'd ended up having to move them again at the end because of the double negative on that. Okay. So that's why we wait till the end to do that. Let's say we had x, y squared, z to the negative 3 raised to the negative 5 power. Multiply again, so that'd be x to the negative 5, y to the negative 5 times 2 is 10. And z would be raised to the negative or positive 15. Good job. All right. So we've applied that property. Now fix them. Which ones move? The x and the y need to move because they both have negative exponents. So we're going to move those to where? The bottom. So the bottom part is going to be where's that at? Top. Z to the 15 on the top. Good job. Not too bad. Not too bad. All right. Let's throw in some numbers. And say we had 2x to the negative 4, y to the negative 2 power. I'm getting too big with the numbers here. Think a little bit here because there's a number involved. We're going to go ahead and work that out and simplify that number at the end. Okay. All right. So what's that going to give us? What's the exponent on this 2? Right now, it's a 1, right? When I multiply, the rule is to multiply those two. So negative 2 times 1 would be 2 raised to the negative 2 power. X to the positive or negative 8? Positive 8. Y to the negative 2. Because that's a 1 exponent as well. Now, which ones of those move? The 2 and the y are negative, so they need to move. Okay? So that's going to be x to the 8th on top. 2 squared on the bottom. Y to the 2nd on the bottom. Now we can work out 2 squared is 2 times 2 would be 4 y squared. And there is the simplified version of that. Out of that. So we're applying the exponent properties, fixing the negative ones after we've applied all the exponent properties that are there, and then work out your numbers. Should have positive exponents on those when you're working out numbers. Okay. If you've got negative exponents and you're trying to work out a number, you're not done yet. All right. Let's throw in some division. What was the rule with exponents with the bases the same and you're dividing? Subtract. So if we had x to the negative 7 over x to the 6th, the rule is to subtract those exponents, right? What's negative 7 minus 6? X to the negative 13. And remember, we talked about this on Thursday. Anytime we do that division, we want to move the answer where? Always put it where first? On the top first. And then we're going to, now since we've introduced negative exponents, we've moved it to the top. Technically, it's x to the negative 13 in the numerator, in the top part of the fraction. To fix it, we need to move it where? To the bottom. So that'd be 1 over x to the 13. And say we had x to the negative 7 times x to the 5th over x squared y to the 8th times y to the negative 3. Okay, so I can do those x's up top first. So what's the rule for the x's on the top? Add, because they're multiplying. So if I just look at the top part of that, it's multiplying things with the same base. So if they've got the same base, both of them are x's, I'm going to add those exponents. So it'd be x to the negative 7 plus 5 is negative 2. Be careful on your adding and subtracting positive and negative numbers. Okay. On the bottom, does this x squared do anything right now?
No.
Not yet. We're going to use it in a second. So it's still there. What about the y's? 8 and negative 3 would be, is it negative 5 or positive 5? 8 plus negative 3. Positive 5. Now, what's the next exponent rule that needs to be done? Nope, don't need to move it to the bottom yet. Subtract, because we're doing what? What does this big fraction mean? It means division, right?
Yes.
So negative 2 minus 2 be x to the negative 4. And remember, when you do that subtraction, it's always top minus bottom, and then the answer always goes where? Top. Okay? X to the negative 2 over x squared. Negative 2 minus 2 is x to the negative 4. Okay, so we have that answer in the top. Now we fix any negative exponents. So now this guy needs to move, right? 5 to the 5th. It was already positive, so I don't need to move it. What's on the top now? 1. Everything else moved off, so 1 is all that's left. Okay. Let's say we had 2x squared y to the negative 5 all to the negative 3 power. Multiply what? Yeah, that 2 has a first power. That's what Tyler's trying to tell us here. This 2 has a first power. And the rule is to multiply all these exponents. So we end up with 2 to the negative 3, x to the negative 6. Good. Y to the positive 15. All right, good. Okay, so we've applied that exponent rule. Now we look to see if there are any other exponent rules. Doesn't look like there are. The only thing we got to deal with are the negative exponents. All right, so the 2 and the x need to move, right? Because they both have negative exponents. So the y to the 15th stays where it's at. On the bottom, we get 2 cubed, x to the 6th. What is 2 to the 3rd power? 2 times 2 times 2 is, try again. 2 times 2 is 4, times 2 is 8. We end up with that as the simplified version of that. The good thing about the negative exponent rules, we're still working on the ones from last week. So if you weren't really great at those and you struggled a little bit with the quiz Friday, hopefully you're getting better at them this week. In this Friday's quiz, you'll be able to knock that out because you'll know those rules much better. Let's say we had parentheses 3x to the 5th y squared. Close the parentheses to a negative 2 power. And on the bottom, we've got 12 x to the 3rd y squared. All right, so parentheses, order of operations, parentheses comes first. So we look at that, and we got negative exponent of a negative 2 there. So we're going to end up with 3 to the negative 2, x to the negative 10, y to the negative 4. The bottom part, is there anything that I can do to that? No rules to even apply. So I've just got 12 x cubed y squared. Now, are there any other exponent rules that I can use? The x's and y's are doing what operation? It's written like this. They're They're division, so the rule for the exponents is subtract them. So we got x to the negative 10 and x to the third. So negative 10 minus 3 is, try x to the negative 13. Negative 10 minus 3 means it's getting more negative. Like you owe me $10 and then you borrowed 3 more. Now you owe me 13. Okay. Negative 4 minus 2 would be negative 6. What's still on the bottom? The x cubed and the y squared are gone now because I used them when I did this. Okay. So the 12 is the only thing that's left there. Okay. When you use that exponent rule, the bottom part's going to go away as far as the variables go. Okay. That number is going to stay there. Now, rule is move your negative exponent stuff. We got all 3 of them up on top are negative, right? So that means every one of them's got to move. Down to the bottom. Now, that 12's still there. When I move that 3 to the negative 2, when I move it down, it's going to be times 3 squared. Okay, it's always going to be times your multiplication that you're going to make. Put that stuff together. And then we would have x to the 13th, y to the positive 6 now, because we moved it down. What's on top? 1. Now we need to work this out. What's 3 squared? 3 times 3 is 9. What's 9 times 12? Close. 9 times 12. 108. Good job. 108 is the number that's on the bottom. So 1 over 108, x to the 13, y to the 6th. That one had almost every property that we've done. Not quite, but almost. Let's try this one. 2x to the negative 2 times y to the 5th over negative 4 x to the 2nd y squared. Several examples there. We just got this one and one more, maybe, unless we have some misunderstanding here. Then we might do one more. Okay, so got parentheses there. That always draws our attention, makes us do that first. That's 2 to the negative 2, x to the negative 2. Still got the y to the 5th. Anything I can do on the bottom. Doesn't look like there's no bases that are the same. There are no parentheses just on the bottom out of that. So there's really nothing I can do there. All right. So what do I do with the x's and y's? Subtract, because they're doing division, right? So negative 2 minus 2 be x to the negative 4. The next step, we got the 2 to the negative 2, x to the negative 4. And then we have 5 minus 2 is positive or negative 3? Positive 3. And what's left on the bottom? Just the negative 4. Remember, when we do that division and subtract these variables are going to go away every time. Okay? As long as there's a base up there that's the same on the top. All right, that negative 4, is it going to move? Is the exponent negative or just the number? Just the number. It's okay to have a negative number in the denominator, so we're going to leave it there. What's the 2 to the negative 2 going to do? It's going to move to the bottom, right? So we got negative 4 times 2 squared. Does the y move? No, it's going to stay up top because it has what kind of exponent? Positive already. So I don't move it. If it's already got a positive exponent, don't move it. Okay. Now I just need to work this out. What's 2 squared? 4. 4 times -4 would be -16. X to the 4th. And then the y to the 3rd still up top. There's our final answer for that one. What letter are we on here? T. All right. Maybe this is our last one. So 2x to the -1, y to the 2nd squared over parentheses -2x y to the 2nd all to the -3 power. This one be a little bit difficult. Parentheses first. I was right on top of that. The order of operations always is in charge. So parentheses and then exponents. So we went with 2 squared. -1 times 2 would be -2. Y to the 2 times 2 is 4. So that's our numerator. The bottom part, we got a base of a -2. So that's going to be -2 to the -3 power. So notice I put that -2 in parentheses because it matters. Okay. X to the -3. Y to the -6. I knew what you meant. All right.
No. There's a lot of negatives in this one.
A lot of negatives in there, but are there other rules that we need to do first? And I'm on example T. You're better when you understand you do. I promise. I promise. I'm doing this enough time. All right. So what do we do before we deal with those negatives? Robert's right. There's a lot of negatives in here, but we got to deal with something else before we deal with the negative exponents. X's and Y's. There's a division there, right? So let's take care of that rule before we deal with the negative exponent. Maybe this rule takes care of some of those. So are these bases the same? No, one's negative, one's positive. They're not the same. They're very similar, but they're not the same. Okay? These bases are the same, the x's, right? So we got -2 minus -3. Try again. +1 is the correct one. So 2 to the 2nd power, x to the +1. -2 minus, you didn't do the double negative there, you just did one negative. That's what it was. All right, and then 4 minus -6. 4 minus -6. Negative. Is it negative? 4 minus -6. Double negative right there, so that's plus positive, so that'd be 10. And then on the bottom, we got the -2 to the -3 power. Hey, that took care of a lot of those negative exponents. Look at how many there were here. There's 1, 2, 3, 4 right there. And then we did that step, and now there's only one. So that made it a lot better, right? So what happens now? How do we fix the negative exponents? It's on the bottom already, so I'm going to move it where? To the top. So I got -2 to the +3, and then 2 squared is going to stay up there. It's got a positive exponent. X stays up there. It's got a positive exponent. What about the y? Does it stay there or go down? Why does it stay up there? It's already positive, so you don't move it. And then we work it out. What's negative 2 times negative 2 times negative 2? Negative 8. What's 2 times 2? 4. What's negative 8 times 4? Negative 32. X, y to the 10. So that big ugly problem that we started with there, right here, simplified down to be something that's not so bad. That's why the exponent rules, that's what we're trying to do, is just simplify things down and get them to the lowest terms that we can out of that. Now, are you going to do this in the grocery aisle at Piggly Wiggly? No. But knowing the order and the process that you're doing things is what we're trying to teach here. Is not necessarily something that you're probably going to do in life every day, but more of a thinking process and following a set of rules that help you make decisions. That's what we're trying to teach, because everything we do in algebra class is not something you're going to do every day. You're not going to write an essay every day of your life either. Like you do in English class, you write something every day. You don't do that in everyday life either. So is this something that I can apply directly to your life? Probably not. But it's something we got to learn this process, learn to do this. It's going to help us learn to do something else that if you're an engineer, you may end up doing every day out of that stuff. So the algebra is a big part of learning to do that. So we're just trying to build up a thinking process. All right. So that gets us exponents